Good day everyone, I'm Alicia Manta, and in this video I'm going to be explaining two items from the final problem set of my calculus class. So we can see here that we have to evaluate the antiderivative of 5 over 2x minus 1. So we can see here that we can use the chain rule since we can evaluate 2x minus 1 and also 5 over 2x minus 1. So which will be the u here? So we will assign the inner function the u, so that would be 2x minus 1, which would mean that du over dx is equal to 2, which can then mean that dx is equal to du over 2. So when we rewrite the statement with u, that would make it 5 over u times du over 2. 5 over u replaces 5 over 2x minus 1, and d over 2 replaces dx. And then when we combine it together, we get 5 du over 2u. And since 5 over 2 is a constant, we can take that out, so that would be 5 over 2 with the antiderivative of du over u. And then we can also make du over u 1 over u times du, which is essentially the same thing. And according to the theorem that 1 over x dx is equal to ln an absolute value of x plus c, we can rewrite this as 5 over 2 ln absolute value of u plus c. And then if we insert the value of u, that would mean the final answer is 5 over 2 ln and then absolute value of 2x minus 1 plus c. So the c is any arbitrary constant. That is the final answer. So for our next problem, we have to find dy over dx of y is equal to square root of tangent x squared minus 1. So in this problem, I can see that we need to use the chain rule twice, because we can see here that there is an inner function x squared minus 1 within an inner function tangent x squared minus 1 within another inner function, outer function actually, which is the square root of tangent x squared minus 1. So what we can do here, since the formula for the chain rule is the derivative of the outer function evaluated at the inner function times the derivative of the inner function, we can write it like this. So we will first find the derivative of square root evaluated at tangent x squared minus 1. So since this is just equal to tangent of x squared minus 1 times raised to 1/2, so we can just make that the derivative 1/2 tangent x squared minus 1 raised to negative 1/2, and then we can multiply it by the derivative of the inner function, which is tangent x squared minus 1. So that would make it times secant squared of x squared minus 1, and then we have to get the derivative of the inner function, which is x squared minus 1, which would be 2x. So that is using all the rules of derivatives. And then we can see here that we can move this one. Oops, sorry, I forgot that. We can move this function here at the bottom. So we can rewrite it as secant squared x squared minus 1 times 2x. And then we will move this down, so we got 2 times, so since this is raised to 1/2, we can just make it square root again, so that's tangent x squared minus 1, which would then be simplified. We can cancel the 2 here, these two, which would then equal to x times secant squared, x squared minus 1 over the square root of tangent x squared minus 1. This would be the final answer.